Some of the racing lines at the Dutch Grand Prix were very strange, particularly at turn 3. It looked like the drivers were taking more of a wet line. So why were the drivers doing this? Well, in this video, I'm going to explain what they were doing and how it was faster. So first of all, I think it's important to explain what a normal racing line would look like around turn 3 if it were flat. So typically you'd have two styles of racing line coming into turn 3. You'd have the one where you are on the outside of the corner, a nice late apex, coming back in, hitting the apex around here, about 3/4 of the way around the corner, and then getting on the accelerator, trying to straighten up the car as much as you can. This is focused on late braking, a later turning point, hooking the car around and getting on the accelerator as quickly as you possibly can. Then we have more of a V-shaped racing line, something that you might see someone like Sebastian Vettel use in a corner like this, in a hairpin corner. So he might come in, brake in a straight line, but then dive across to make a first apex quite early in the corner. Then allow the car to push out to the mid corner where he rotates the car, gets the car to turn. Yes, with this type of racing line, you would have a lower minimum corner speed, meaning the car is going slower. However, you have managed to brake later and do more of the turning in the mid corner. From this point, you manage to turn the car, and because you've turned the car so much in the middle of the corner, the exit of the corner is a bit straighter and you can accelerate quickly out of the turn. And that's what you typically see at normal corners. For example, Luffield at Silverstone, it has a similar radius to turn 3 here at Zandvoort. However, as we know, turn 3 is different. It uses a lot of banking, and this is nothing new for racetracks. We see it a lot in America, and especially on the ovals, where the circuit is banked so cars can potentially run side by side. In fact, we even see it on the public roads, on corners that might be deemed to be slightly dangerous. However, turn 3 at Zandvoort is very unusual in the fact that the angle increases as you go up the banking. In fact, at the bottom here, the angle is only 4.5 degrees, whereas at the top of the banking, it's actually 19 degrees. So you can see that it's more of a bowl than any normal type of banking. And while the absolute angle of the banking isn't that high, it's 19 degrees here at Zandvoort. And for example, Daytona uses a 31-degree banking. It's the fact that it curves up as you go steeper up the incline. So let's get into why the high line. Well, the first thing to look at is the braking going into turn 3 and the differences between taking the higher line and the normal ideal racing line. If we jump on board with Max Verstappen here, you can see the curvature of the track here. You can see the inside line here where you would be braking. The circuit falls away as you head down there. Now, as we know, and as we see a lot in Formula 1, when drivers turn into the apex of the corner, we often see the inside wheel, the unloaded wheel, locking up as they enter. Whereas if Max comes on the outside of the track here, the circuit is flatter for longer. This means that the weight of the car is more evenly distributed across the front axle. This then means that that load is pushed into the track more efficiently, and Max can brake later for turn 3. The second thing that helps the deceleration, the braking phase of the wide line, is the banking itself. As the driver approaches and is still on the brakes coming into this point here, because the banking is coming up, the car is going uphill. This not only slows the car down because it's going uphill, but also there's more load going through those tyres again, so the driver can brake even harder and therefore decelerate even more quickly. So because the banking isn't linear, because it ramps up in the angle as you come up towards the outside of the banking here, the higher that you go up there, the more the vertical load is going through the tyres. Imagine you're running around a wall of death. The reason that those motorbikes can go round and round in circles is because there's lots of vertical load going through the tyre. And that's exactly what's happening here. The higher up the banking you go, the more grip you have. There's also the fact that because you can maintain a higher minimum cornering speed, there's also more efficiency and more downforce with the aerodynamics of the car, because you are able to carry even more speed through that corner. You have less steering to do, and therefore you have more air coming over the car. So even though the inside line, the ideal racing line, is a shorter and supposedly more efficient way through the corner, carrying that extra momentum and that extra speed and that extra downforce around the outside means that it is slightly quicker. One really interesting thing to see from Max Verstappen's car in particular was the amount of steering angle that he was able to put into the car at the mid corner. And this just goes to show how much grip he had out there, how much vertical load was going through those tyres, because he was able to turn the car sharper at this point than almost any other driver. And so onto the exit of the corner. Really important here because the drivers are flat out for quite a long time down the following section of track. So it's important that they're able to lay all of that power into the track. Now, what is important to realize here is that there's still a lot of camber in the circuit. Imagine the corner coming around with the banking, and then as you get into a straight line, the banking obviously comes back to being a flat piece of racetrack. When you go around the outside of the corner, this transition happens over a much longer piece of track. Whereas when you're on the inside of the circuit, you almost drive out of the banking like this, and that can transfer weight across the rear axle in quite a quick way, meaning that if you do go around the outside of the corner, you've got a flatter car when you're getting on the accelerator here, and therefore there's more even weight going across the axle, meaning that you can use all of that grip for acceleration rather than turning. One other thing that affects the exit, the acceleration period as you're coming out of the corner, with the comparison of the two different racing lines. When you're traveling around the outside with that higher minimum speed, you have less acceleration to do as you're accelerating from a higher speed. And therefore the car is generally less traction limited. Now, the reason that I think the track designers did this was so that cars could run side by side in this section. You've got the inside line and the outside line, and the difference between the two was probably very close. And of course, they probably did this so that drivers could overtake, which we did see in some of the lower formulas. The only problem with overtaking here is that if you do dive down to the outside, you do have that shorter line coming through the corner just here. When you come up on the exit, you would have to stay a little bit tighter coming through this point because you have a car on the outside, and therefore you couldn't quite get on the accelerator pedal as early as you would need to overtake another car. However, it did make for some interesting side-by-side action. Thanks for watching this video. Please be sure to subscribe to the Drive 61 channel, and if you enjoyed this video, please check out these other videos which we think you'll love.